Let's look at a left-tailed z-hypothesis test for a proportion. A credit card company found that 17% of customers did not pay their bill by the due date. A manager suggested that printing on a colored piece of paper might make the bill stand out from the standard white paper that comes in various pieces of mail. To investigate whether colored paper will improve the delinquent rate, not paid by the due date, a random sample of 600 customers were sent bills on colored paper. Among this group, 82 did not pay the bill by the due date. Using a 5% level of significance, should you conclude the colored paper improved the delinquent rate? Below are the steps to follow. The steps for a hypothesis test about a proportion: number 1, define the parameter of interest, then identify the null and alternative hypotheses, and remember the alternative is going to define what the researcher is trying to prove. Then set the significance level and give the decision rule. Check the validity conditions. Give the formula to obtain the test statistic, then calculate it based on the sample collected. Then calculate the p-value, or the probability, based on what you got for the z-score and the alternative hypothesis. Finally, make your decision and provide a summary. The parameter P represents the proportion of all credit card companies' customers who do not pay their bill by the due date. Now the hypotheses, for the null hypothesis, you're going to give a parameter and the value it's assumed to be equal to. So H sub 0 is P equals 0.17. For the alternative hypothesis, decide what the manager wants to prove or find evidence in support of. Notice that an improvement would imply the rate is lower, so a smaller proportion of people are not paying the bills on time. HA, P is less than 0.17. Decision rule. The level of significance is alpha equal to 0.05. So 5% level of significance. So the decision rule is written like this. If the p-value is less than or equal to 0.05, then reject the null hypothesis, H sub 0. Although we don't write it down, this implies that if the p-value is larger than 0.05, then fail to reject the null hypothesis. Now consider what is called the validity check. Is it okay to do the hypothesis test? A random sample is taken and the data collected is categorical. Did the customer pay the bill on time or not? N times P is 600 times 0.17 from the null hypothesis value of P. That equals 102 successes expected, and that exceeds 10. And N times 1 minus P is 600 times 0.83, or 498 failures are expected, and that also exceeds 10. The one sample z-test for a proportion is appropriate since the validity conditions are met. Now let's move into the test statistic. The test statistic can be partially filled in without information from the sample. Actually, in research, the decision on what to use as the test statistic is typically made in the design phase of a study, and then the sampling can be conducted to ensure the conditions are met to use the statistic legitimately. In this case, a large enough sample size was taken to be certain the z-score was appropriate. If the sample had not already been discussed, you could still produce this much of the test statistic step. Z equals p hat minus p over the square root of p times 1 minus p over n, and then filling in p hat minus 0.17, that's the value of p from the null hypothesis, divided by the square root of 0.17 times 0.83 divided by 600, and simplifying, that would equal p hat minus 0.17 divided by 0.015335. And that's keeping 6 digits. Adding the sample information, 82 of the 600 did not pay the bill by the due date, produces the calculated value for Z, often called the observed value of the test statistic, based on the sample collected. Notice this truly is a statistic. If you repeated the study, it's likely you would not get 82 people who did not pay by the due date. That change in number would change the sample proportion p hat, which would also change the overall value of the z-score. But in our case, the z-score we can complete by putting the 82 over 600 in, converting that to a decimal, 0.136667. That's difference in the numerator is negative 0.033333 over the same denominator, and that produces a negative 2.17 for our z-score rounded to 2 decimal places. Now consider the p-value. Since HA is attempting to show the value of p will be smaller when using colored paper, then a sample proportion that is this small or even smaller would support HA. Imagine if instead of the sample proportion being 0.136667, it had been 0.10 or 0.08 or even smaller. Then the z-score would still be negative, but it would be larger in the number part, or the magnitude. So values in the left tail of the standard normal curve support the alternative hypothesis. Hence we find the probability, or the p-value, as the chance the z-score is negative 2.17 or to the left of this. This is why we call this a left-tailed test. Values in the left tail of the normal distribution support HA. The p-value is the probability z is less than or equal to negative 2.17, which from table Z or from technology is 0.0150. Is the p-value less than or equal to 0.05? Yes. So based on the decision rule, you reject the null hypothesis H sub 0. In summary, at the 0.05 level, there is significant evidence to conclude that the percentage of all delinquent customers, those who do not pay their bill by the due date, if bills are sent on colored paper, would be lower than 17%.